Hi, my name is Lori, and I'm a support engineer with GeoSLOPE. I've created a series of getting started tutorials for new users to GeoStudio. So if you're brand new to using the GeoStudio software and you're not quite sure where to start, then you've come to the right place. These tutorial videos have been designed to help walk you through the basic steps of creating a simple model using GeoStudio. The main topics that will be covered in this series will be how to use define to set up a numerical model, using the solve module to compute the numerical solution, and how to use contour to view the results and to gain a deeper understanding of the problem you're modeling. You can pause, stop, fast forward, or rewind these videos at any time by using the controller bar positioned at the bottom of the window. If English is not your first language, you might find it helpful to print out a copy of my script, which is available as a PDF from our website. So let's get started. Here's the profile we're going to model with sigma W to determine the settlement of a circular water-filled tank. The upper 5 meters of soil have different properties than the underlying 20 meters. The tank is 10 meters in diameter with an applied pressure on the ground when the tank is full of 40 kPa. Since the profile is symmetrical around the vertical center line of the tank, the problem will only include half of the tank and will conduct an axisymmetric analysis. An axisymmetric formulation considers the stresses in the xy plane as well as the circumferential stresses, and the profile you create is rotated around the axis of symmetry. We start by creating a new sigma W project from the Start page of GeoStudio. When the Key in Analyses dialog box appears, select what type of analysis you're going to do, in this case, a load deformation analysis, and give it a name and description. Notice that by default, a single time increment is defined, so the load of the tank will be applied in one step. The first time you start working with GeoStudio, it's helpful to learn what different toolbars exist. Many of the drop-down commands are also available as individual icons on the many different toolbars. You can familiarize yourself with the toolbars by toggling them on and off. When developing a numerical model, the first step is usually to set the working area, which defines the size of the space available. The working area may be smaller, equal to, or greater than the printer page. The next step is to set the scale. The scale should be set such that the minimum and maximum extents match those required for the analysis. Define the x and y extents to find an approximate scale, and then fine-tune it so you're working with a 1:1 aspect ratio. This is also where you define that the analysis will use an axisymmetric view. A background grid of points will help you draw the problem. And it's always a good idea to save your file frequently. It's often helpful to sketch an axis. First, click on the Zoom page icon to maximize the view. The axis is drawn by moving the cursor from the bottom left corner and stretching it outward. The number of increments can be adjusted using the Set Axis drop-down menu. Before defining the geometry in sigma W, it's convenient to first sketch the problem. Select Polylines from the Sketch menu or use the Sketch Polyline icon. Use the cursor like a pencil, clicking the left mouse button to create a series of lines. The lines are considered objects, which can be adjusted or deleted by using the Modify Objects command. Text can be added to the profile using Sketch Text. Use the cursor to place the text on the profile. The approach to use when developing a numerical model is to draw the geometry, create and assign materials, create and assign boundary conditions, and then finally to review and fine-tune the finite element mesh. Let's start by drawing the geometry. Individual soil regions are created using the Draw Regions command. Click the left mouse button to create region points. Once the polygon region has been closed, you can either continue to draw additional regions, or you can right-click the mouse to exit Draw Regions mode. We want to have a finer mesh right under the tank where the stress changes will be the highest, so a couple extra regions are created so that the finite element mesh can be better controlled. Materials are first created and then assigned to geometry objects. Choose Materials from the Draw drop-down menu. Click on Key In to create a material. Add a new material, name it, and select the material model from the drop-down list. For this case, we'll be using a linear elastic total stress model. Only the stiffness modulus and Poisson's ratio are required. To create a second material, you have options. You can either add a second material as we did the first, or you can clone an existing material if they're similar. The materials can now be assigned to the individual geometry regions. Boundary conditions are created and assigned in the same way materials are. Select Boundary Conditions from the Draw menu. For this example, we are only going to use stress-strain boundary conditions. There are already 3 commonly used boundary conditions available for you to modify or use, and you can also create your own boundary condition by clicking on the Add button. We need a boundary condition that will reflect the pressure of the tank on the ground surface. The negative value means that it's acting downward. Once the boundary conditions have been created, you can then apply them to the region geometry. Along the left symmetric axis, we want to allow vertical settlement, but we want to restrict any lateral movement. Along the bottom and right vertical sides, we're going to assume that these boundaries are far enough away from the applied pressure that the movement can be fixed in both the x and y directions. Boundary conditions can be applied to region edges, region nodes, region faces, free lines, or free points. To break up a region edge so that you can apply the boundary condition, such as the tank pressure, to only a portion of the edge, you may need to insert a region point. Boundary conditions can be easily removed from the geometry as well. Now that the geometry has been drawn, the material properties created and assigned, and the boundary conditions applied, it's time to review the finite element mesh and make any necessary adjustments. You can view the finite element mesh using Draw Mesh Properties. The meshing algorithm in Sigma W is defaulted to use a global element size. The meshing pattern consists of quads and triangles. For this simulation, we want to use a structured mesh of quadrilateral elements only. To make the mesh more coarsely discretized, type in a larger global element size and then hit Enter, or select anywhere in the geometry, and the mesh will be updated automatically. By holding down the Shift key, you can select multiple regions to make a common change to the mesh, such as using a structured or rectangular grid pattern. Under the footing, an even finer mesh is preferred. You can apply meshing constraints to individual geometry objects by selecting the region and then applying the constraint. In this case, the element size in this region should be half that of the global dimension. In addition, 8 noded elements will be used under the tank, while 4 noded elements will be used for the rest of the mesh. The number of nodes in your finite element mesh will affect both the size of your file and the amount of time required to solve the problem, so it's prudent to only use secondary nodes when necessary to obtain a better solution. After you leave the Draw Mesh Properties view, the finite element mesh will disappear. If you want to leave it on, you can click the View Mesh icon in the View Preferences toolbar. Now it's time to verify the problem. Click on Tools Verify, and Sigma W will run a number of checks to see if there are any errors in the problem definition. The solver for Sigma W can be launched by clicking on the Solve icon. Click the Start button to activate the solver. You can view the results directly by clicking on the contour icon in the Analysis toolbar. Y total stress contours will appear by default, which you can label using Draw Contour Labels. The contours form a pressure bulb, much like the ones that are typically shown in most introductory soil mechanics textbooks. One of the main objectives of this simulation was to determine the vertical settlement of the water-filled tank. Select Vectors from the Draw drop-down list. In Sigma W, you have the option of viewing the displacement as either vectors or a deformed mesh. The maximum displacement is also summarized in the dialog box. You can also turn on or off the deformed mesh using the View Preference icon. We can also draw a graph of lateral displacements under the tank. Choose Graph from the Draw menu. Add a new graph and select the parameter you want to graph. Let's take a vertical profile on the outside edge of the tank. Another way to view the results is to create a More circle. Choose More Circle from the Draw menu. Move the cursor and select either a node or a Gauss region where you would like to know more information about the stress results. You can also spot check results at specific nodes or elements using the View Result Information command. By holding down the Control key, you can select several points at the same time. New to GeoStudio 2007 is a reporting feature. If you need to generate a report of your input data, select Report from the View menu. Once you save the report file, your default word processing program will open with a generated report. You can now insert pictures, apply style templates, or add and delete data. To return to the Define view, click on the pencil icon in the Analysis toolbar. If at any time you need help understanding a dialog box, you can click on the question mark in the top left corner to access the online help or use F1 on your keyboard. You can also switch to the Analysis Start page, which has PDF copies of all the engineering books for GeoStudio under the Documentation section. These books are very helpful in describing the features in the software and the theory behind them. You can also search through the examples database using specific keywords. And when you're done, you can return to your analysis by clicking on the Analysis list. One of the powerful new features to GeoStudio 2007 is the ability to run many different analyses within the same project file. You can add a different type of analysis, or you can clone an existing one if you just want to change a few parameters. The geometry is considered project-specific, but you can change boundary conditions, material properties, or strength models. We have reached the end of this introductory lesson. Not all of the powerful features of Sigma W have been used or discussed during the lesson. Specific details about each command are given in the online help and in the supporting documentation for Sigma W. Thanks for watching.